Most of the papers that talk about El Nino impacts on the monsoon tend to be about seasonal monsoon total. So when we say El Nino produces a deficit in monsoon, La Nina produces a surplus, we are talking about seasonal totals. There are a few papers that look at the evolution of El Nino correlations with the monsoon through the season, June, July by month, or by intraseasonal timescales. And intraseasonal timescales are very important because it's one of the most intrinsic timescales of monsoon variability, active break periods as we call them, and farmers obviously depend on them very heavily for their crop calendars and so on. And we talk about 10 to 20 day events and 30 to 60 day events, and people talk about whether flood years are associated with more active periods, of drought years with more break periods, and how global warming is changing active and break periods. There are a couple of papers that talk about Indian summer monsoon intraseasonal oscillation with El Nino, and this particular paper I'm starting with talks actually about what happens to these during the developing phase of an El Nino, the decay phase of an El Nino, and during the El Nino itself. We'll look at another paper that talks about active break periods during the El Nino itself as well. Uh, as we talked about before, the number of samples of El Nino is already relatively small. So if you want to look at evolution phase, decay phase, and distinguish them from El Nino phase, you are obviously going to have same sampling issue. So let's read the abstract and look at a few figures. Then you can try to convince yourself whether the results look uh, you know, impressive enough to say there is in fact a stratification by decaying phase, evolution phase, and El Nino phase on intraseasonal oscillation. Intraseasonal oscillation can also mean monsoon intraseasonal oscillation, which is the propagating part from the deep tropics into the Bay of Bengal, which then produces low pressure systems, but they are closely related to active break as well. So you can get into those details. I've discussed them elsewhere. The present study investigates the characteristics of active and break cycles associated with the Indian summer monsoon during developing and decaying phase of El Nino and in the years in which Indian Ocean dipole co-occurred with El Nino. Observations show that break days are more in number, so 2 to 3 times, and long lasting, so 15 to 20 days, than active days in El Nino developing summers, and vice versa for decay years. So if you then go into IOD, co-occurring IOD, independent IOD, then you keep reducing the number of samples even further. But nonetheless, during El Nino developing years, northward propagation is well organized in with significant anomalies in both active and break phases. So we are talking about onset of recharge and the onset of El Nino. So we'll see how they define these things. The increased convection associated with active phases, active phase persists longer over the Indian Ocean than over the monsoon region, while the reduced convection in break phase propagates faster from ocean to land and persists there for a longer time. So they are talking about propagating features. Compared to break events, active events have slower propagation over the monsoon and faster propagation over oceanic region during El Nino decay years. The present study put forward the argument that contrasting persistent circulations over the Indo-Western Pacific regions favor particular phase of intraseasonal oscillation in developing and decay phase of El Nino. These long-lasting circulations advect anomalous dry or moist air to ISM regions for a longer period, resulting in long-lasting break or active events in El Nino developing or decay years. They do this parenthesis thing, which is always difficult to read. During co-occurrence years, the number of break days is reduced by 2 to 3 times compared to the developing or decaying, compared to developing phase of El Nino and vice versa for decaying phase. It is found that 30 to 60 day scale ISO is strongly modulated than the 10 to 20 day scale by the changes in seasonal mean state associated with El Nino. Thus, the study demonstrates that the ISO characteristics such as its variance, northward propagation, spatial distribution, and duration of active break days are strongly modulated by seasonal background anomalies over the Indo-Pacific region. So, if we're talking about the Indo-Pacific region, can you really separate IOD, or does it have to be part of the whole Indo-Pacific El Nino as well? So those are all deeper issues. But I wanted to raise this only because obviously you expect if the seasonal totals are getting modulated by El Nino, then they must manifest themselves in active break periods as well. Okay, so there are arguments also that the intraseasonal variability looks like interannual variability and so on. People agree, disagree, and so on. Just to flip through few, again, they do precipitation and 850 hectopascal winds for only El Nino years and associated SST and SLP. Looks like El Nino pattern here, even though it's more like a Central Pacific shifted a little bit. El Nino decay phase and El Nino plus IOD years. So decay, La Nina-like feature appears typical of decay of El Nino. El Nino plus IOD has this plus this signature, even though this is much further south than the equatorial loading that we get during IOD, and you can see there is a corresponding southward phase shift of precipitation and 850 hectopascal winds, and you clearly again see that the Indo-Pacific is a unit as they talk about. So can we consider IOD as something different? But if El Nino plus IOD, then obviously maybe you don't have to worry about whether IOD is independent. I'm just raising these questions because we are always debating these, we are always confusing them as well. Composite anomalies of OLR just again show certain signatures. Obviously, OLR is negative anomaly when convection is happening and it's anomalous dry conditions, then OLR will be positive and so on. So I'm not going to spend time on it, but if you look at the patchy distribution of statistically significant signatures of active and break days during the growth and decay phase of El Nino and during El Nino, are you impressed? Well, you have to take the signature that's important, and maybe you can convince yourself that there are significant signatures over the Indian subcontinent, but not, it's here clear, but patchy here, and so on. So you have to convince yourself whether they can clearly be separated, because explained variance is going to be tricky, right? So there are active periods, there are break periods. They are very important for the monsoon seasonal totals. There are low pressure systems which are associated with propagating signatures, and they contribute sometimes up to 60%, all these things. But more convincing would be to just look at the propagation period features. So this is going from equator to 30 north, and these are lag days here. So latitude and this is the latitude, and these are the lag days. Okay, sorry about that. So active and break periods, and obviously there is kind of a flip-flop between the tropical Indian Ocean and subcontinent. Even though MISOs mostly propagate over the Bay of Bengal, they don't go directly over land. Again, we are talking about El Nino developing, decaying, and during, and there are differences. How significant they are, you have to convince yourself. Okay, but maybe there are more clear propagations happening during break, but here this is more like, you don't see clear propagation here. It'd be a bit of a propagation here. This is standing here, not propagating. These all could be sampling issues as well. There are no doubt that there are propagating features, and there is the local Hadley cell as well, right? When it's convecting over the deep tropical Indian Ocean, it's subsidence and dry over the Indian subcontinent, which is a much more of a thermally direct circulation as opposed to propagating MISOs. So how do they all come together? Look at this to again question yourself, do they really look different? These are the JJS composite mean standard deviation of 32 to 60-day filtered OLR daily anomalies in El Nino developing years, El Nino decay years, and co-occurrence years. Panel D and F are the same as panels A and C, but for 10 to 20-day filtered OLR anomalies. So, they're looking at 30 to 60-day and 10 to 20-day, and concluding basically, if you look at these, the way I would say it is, if this is observation and this is the model, we will say the model is doing reasonably well compared to observations. But we are taking reanalysis and trying to argue that this is different than this one, and so on and so forth. So we are interpreting results in ways, but there has to be a consistent dynamic explanation to go with that. And what they conclude at the end is, altogether the present study concludes that the basic properties of monsoon ISO, such as duration of active break cycles, their spatial distribution, and northward propagation, are strongly influenced by the background state induced by different phases of El Nino and IOD. Furthermore, this study advocates that the better representation of seasonal background anomalies associated with El Nino and IOD in coupled models uh, in order to capture the intraannual variability of ISOs. So ISOs exist, and their intraannual variability happens, of course, because there is also seasonal intraannual variability in the seasonal amounts of rain, which obviously have to come through changes in active and break periods. So I'm going to leave this and we'll read the other one in the next podcast, because I don't want to make these too long. I want to just keep them kind of introductory. I'm being very brief, obviously, but you have to go and read the paper. I'm just introducing the topic literally and not saying much other than making some comments about whether the results look convincing or not. My main problem will be that there are always sampling issues. Even though there are multiple active and break periods in each season, when you take all the El Niños, IODs, developing and decaying phases of El Niños, you end up with relatively small numbers. So you're squeezing out of that active and break periods plus 10 to 20 day, 30 to 60 day, and they also look at dynamic quantities like moisture loading and so on, that you can read and see if you are convinced. Okay.